AET 114, Chapter 19, Example 2. Using superposition, determine the current through the capacitance X sub C. Now that's our capacitive reactance now in figure 19.106, which is this figure here. So we have a current source, we have an inductor, a capacitor, and a voltage source. So the first thing we're going to do is short out the voltage source as shown here. We have impedance Z1, Z2, and we have I prime, which is part of the component going through, which is the current we're looking through going through here, this I sub C. So Z1 is equal to 8 ohms, angle 90, because it's an inductor. Z2 is 5 ohms, angle minus 90, because it's a capacitor. So the current is 0.3 amps, angle of 60, that's given. And E is 10 volts, angle 0. That's shorted out right now. So I prime using the current divider is going to be I, which is the source current coming into this node, being divided right here, times Z1 all over Z1 plus Z2. So when you do the math for that, you get 0.8 angle of 60. And then going to the second part, you open the current source, bring back the voltage source. Now you got a single loop right here. So I double prime is going the opposite way, which is E divided by Z1 plus Z2, which is the total impedance. And then when you do the math for that, you get 3.33 angle negative 90. So then I sub C, which is going the same way as I prime, equals I prime minus I double prime, because I double prime is going the other way. And when you subtract those two things, you convert from polar to rectangular as shown, and then you get this answer here. So notice when we multiply, we use polar. When we add, as we do in this denominator, we use rectangular, and we convert back to polar and divide. Same thing here. This is rectangular here because we're going to add these two impedances together. Then we convert to polar, and then we divide. Over here, same thing. We start off with polar, we convert both of these to rectangular, then we add them together, and then we convert back to polar again.